First of all, how many of you think you were able to do question number correctly? Number 1 correctly. All right. How many of you got to question number 2? Person. How many got to question number 3? I see a few hands at least, but not a lot in here, this region. All right. So first, we will use the box method. And I hope you understand why the box method works. So it's what type of function before I even do that? Algebraic, right? So algebraic, it's the biggest class of functions we have yet considered. Polynomials, rational functions, all of those things are algebraic functions. So limit at infinity with algebraic functions is generally not too bad. So I will box the leading terms. In this case, this limit ends up being the same as limit where x goes to minus infinity of the root of 9x to the power of 6 divided by x cubed. What is that? And here we have to be really careful. What is root of 9x to the 6th power? 3. And then what? And here you fall into a trap. It is 3 absolute value x cubed. The square root of a number square is not that number. So remember this. Root of x squared is equal to the absolute value of x, not to x. Think about root of minus 3 squared. It's not minus 3. It's the absolute value of minus 3. So we proceed. This is divided by x cubed. How do I get rid of the absolute value in this case? X is positive or negative number? Negative, because it approaches minus infinity. So the values I plug instead of x are very large in magnitude with a negative sign. So what I end up having is minus 3x cubed over x cubed. Oh, let me write the limit here. And I end up getting minus 3. That's the right answer. Okay? Pay attention whether x approaches minus or plus infinity. Pay attention to what happens when you take the root. Question number 2. Again, x goes to minus infinity of x plus root of x squared plus 2x. Yes. So here again you have to be very careful. Does anybody have a hunch if this should be a negative or a positive number? Negative. You see, if you look at root of x squared plus 2x, this is actually less than just absolute value of x. So this x is going to push it more to negative. But to be safe, exactly how it's done, what are you doing? What do you do to try to solve this problem? Because this is minus infinity plus infinity. There is a struggle. Yes?
Do you have to do the conjugate?
Yes. So that's not have to, but a very good strategy is to try to do the conjugate. Yes?
Well, why? Sorry.
Why the conjugate? Because you have to understand why this box method works. Right? Infinity over infinity, the box method will work. But here, it's minus infinity plus infinity. What is exactly this value approaches? So it's easier to judge in this form. I want it to be a quotient. So I multiply by the conjugate, and what I get is x plus root x squared plus 2x divided by, well, multiplied by x minus root x squared plus 2x, and divided by, of course, x minus root of x squared plus 2x. The result is limit as x goes to minus infinity of x squared minus x squared, put it in parentheses, x squared plus 2x divided by x minus root x squared plus 2x. So this is limit as x goes to minus infinity of minus 2x divided by x minus root of x squared plus 2x. Now it is in a form where I can try applying the box method. How do I apply the box method? What do I box in the numerator? Both, basically everything, minus 2x. And what do I box in the denominator? Be careful. X and something else. What's the leading term of the denominator? You see the x here. This is root of x squared, so there is another thing hiding here. Do you see that? So you're searching for the leading term, and it's not as obviously written in the denominator. Of course, you see I'm making shortcuts. Make sure that you understand why those shortcuts work. Otherwise, it's arbitrary. Why can't I try doing something like this here? Why can't I just take the box here and the box here? Make sure that you understand what the box method is. Really what's happening is that I cancel the leading powers, and I leave things that melt to 0. That's why in quotient, what ends up happening in the quotient is this is going to be x divided by x. You see, this is going to be x divided by x when I factor things out. That's why it works in a quotient. But here I just have, if I factor out x, I have x multiplied by 0. So something that is large multiplied by something small, and I still am not seeing what's happening. Okay? So in this form, now this is limit as x goes to minus infinity. This is just going to be minus 2x, and the denominator is going to be x minus absolute value of x. Let's actually be slightly more careful here. Let me show you. But we're fine to just do it like this. Yes, sorry. So we do, so that is minus 2x over x minus absolute value of x. So how do I get rid of the absolute value?
Where the x goes, right?
Yeah, so x goes to minus infinity. So this absolute value gives you an extra minus. You agree? Because it has to be making it a positive number. So what you end up having is that this is limit as x goes to minus infinity minus 2x divided by x minus x. You see what I did? Minus x here. So, yes?
That's because of the minus.
That's because there's a minus here, but the absolute value by itself. I just ignore this minus. I just look at the absolute value. The absolute value is supposed to make the number positive, but the number is negative. So the absolute value multiplies it by an extra minus 1. So be very careful. You see, you can be confused if you look at this. Just try to take the pieces out and see what the pieces each represent individually. So what you have is limit as x goes to minus infinity of minus 2x divided by 2x. Correct? This is just 2x, which is then negative 1. Let me ask you back into question 1. Do we have a horizontal asymptote, a vertical asymptote, a slant asymptote? What do we have here? Or neither?
It's a horizontal asymptote.
This is a horizontal asymptote. Its equation is? What's the equation of the horizontal asymptote?
Negative 1.
In this case, but again, you just mentioned part of it. What is negative 1? Y equals to, in this case, horizontal asymptote y equals to minus 3. In this case, horizontal asymptote y equals to minus 1. Remind me what's the meaning of a horizontal asymptote. What's an asymptote in general? What is this saying? We're saying there is a horizontal asymptote y equals to minus 3. What are we saying? Yes?
If it goes long enough, it reminds us of minus 3.
Exactly. So if you look at this equation, which might appear to you very complicated, if you draw this equation and you scroll with your screen farther and farther in this direction, to the left, eventually what you begin seeing is that it looks like the simple horizontal line y equals to minus 3. The graph becomes very similar to this graph. You understand? So what you're doing when you're considering asymptotes, you're considering a simpler curve that you are using to describe something, right? Like what's the description of alarm? Of the light bulb. Light bulb is the English word. In German, it's Glühbirne, which means very hot pear. So it describes what a lamp is. So that's what horizontal asymptotes, vertical asymptotes, all those asymptotes do. Is you're comparing something more complicated, something unknown, to something more familiar, correct? All right, so now finally question number 3. Question number 3, I think I said, what's P of t? P of t was minus 3t squared, correct? What was then plus 2t? Plus 1. So this is the position of a particle at time t. So in essence, it describes a horizontal moving particle, a particle moving on the horizontal axis, and it tells you its position in terms of time. This is the conversion of time to position. What we want to find out is the instantaneous velocity. We want to find the speedometer. What's the speedometer pointing as a function of time t? How do you do that? Well, you calculate the average velocity. So v of t is the limit of the average velocity where you took two measurements. One measurement was s, and the measurement s is very similar to the moment time t. And then here you have p of s minus p of t divided by s minus t. You could have used another letter if you wanted to. So what we did here is we see, if I need to measure the velocity at the moment t, what do? I will take this video and I will pause it exactly at the moment t, whatever that number may be, right? And then I press play and press pause. S is the time when I press pause. And I want to do it very fast. So S should be very close to t. But in general, if I just press play and pause, I have the new position at the time, s minus the old position divided by the difference in time. Do you understand this equation? Right? Everything, whenever you're writing something, try to not memorize. Just try to understand why this is very natural. Then everything makes perfect sense. Do I need to explain more? Or you understand? I can explain more. OK. You should have an image in your mind. Here is a moving particle. If you press pause at moment t, the particle is in position p of t. That's how it works, okay? What happens if I press play? I mean, disregarding the particular equation, if I press play at this moment t, my new moment is going to be moment s. So this new moment s corresponds to a new position p of s. Correct? So that's what I in general will observe if I just play this video. There is t, for that there is p of t, the position at this moment. At moment s, there is another position p of s. Now if t is and s are very close, then the displacement, basically the particle did not have too much time to change speed, correct? If you think about a car, you change speed by pressing the brake or by pressing the acceleration. And this takes time. In order for the brakes to take effect or the acceleration to take effect, you need some amount of time to elapse. So if you allow very little time to elapse, there was very little chance for the change of velocity. So if s is very similar to t, the ratio of p of s minus p of t divided by s minus t is a very good approximation to the actual velocity at time t. And it's going to be a perfect approximation in the limit. Yes?
Is the reason that you put the function p of t second, or you're subtracting it from p of s?
This is arbitrary. If you multiply it by -1, it will be reversed. Right?
Okay,
it will be reversed, and it will give you exactly the same thing.
I wouldn't think to multiply it by -1, but I'm asking, is it more so like final minus initial?
It is final minus initial. Why not? Right? You can think of it this way. All right, and then in doing the actual calculation here, this is limit as s goes to t, and what is p of s? P of s is minus 3s squared plus 2s plus 1. That's p of s. Minus p of t, which is the same exact thing. Running out of space here a little. You mind if I erase this picture that I just drew here, the box? I might draw it elsewhere. So here, I just rolled it out. So the first very crucial moment. Otherwise, you see, what you're doing is going to make no sense and no sense and no sense. I want you to see a picture. I want you to understand why this equation is natural. If you do, it's very easy to figure out what you're doing with derivatives. It's very easy to survive for the exam. If you don't, it's enormously challenging. Right? It's very difficult to pass a test in Chinese if you don't understand Chinese, but just try to memorize the symbols. Correct? Yep.
So if I would do it like the other way, where you just like multiply 3 times the exponent and find the derivative, would you mark that wrong? Since I didn't do it your way, where you did.
Well, in the way I phrased it, that is not going to be marked wrong. But I'm going to test for your understanding to be able to do that by definition. If you know some shortcuts, that just means you memorize some shortcuts. But do you know why they work and when they work? Okay? I will test specifically if you can do it by definition. But you can use, you see, based on the phrasing, I just told you, find the velocity. So based on the phrasing that I had there, I did not ask you to do it by definition. So it would not have been marked wrong. On the exam, it will be written explicitly, do it by definition. If so, doing it with a shortcut will not count. All right, so this will be what? So here is a strategy to solve it. So what you want to do is, you see that this term with s squared and this term with the t squared, they are similar. What you're going to do is you're going to regroup this equation by taking similar parts together. So this is limit as s goes to t of minus 3s squared plus 3t squared plus 2s minus 2t and plus 1 minus 1, so those things, they just vanish. The constant terms just vanish, divided by s minus t. So this is limit as s goes to t of, I can factor out here minus 3. So I can write this as minus 3. And here I can write s squared minus t squared will be s minus t, s plus t. And I can write here s minus t plus 2 s minus t over s minus t, and this is just 0. Okay? So this is what you call algebra. You just group it around. This is the difference of squares. You factor the difference of squares, and then you're able to cancel. Cancel. And well, now the limit is very simple. Now the limit s approaches t. So this will be minus 3 t plus t. So that would be minus 3 times 2t plus 2. So the final answer is minus 6t plus 2. This gives you the velocity at any given moment of time t.
Professor?
Yep.
Can we use the limit as h approaches?
Of course, that's exactly identical. It's just, you see, there are many ways of writing exactly the same thing. There are synonyms. One thing I want you to understand is never look at the literal symbols. That doesn't ever matter. Just look at what it means.
Oh, I'm gonna get 2t.
How did I get to t? Once I cross out s minus t from the numerator, I'm left with minus 3 times s plus t. Now s was just some number that is supposed to be a good approximation to t. It's supposed to be very close to t. It's sliding towards t. So s plus t is really imitator t plus the actual t. Correct? Limit. Basically s approaches t. So this will be t plus t. That is 2t. And there is a minus 3 in front of it. So it's minus 3 times 2t. Correct?